the last class, we did this question number 4, I think. Did we complete question number 4? A positively charged alpha particle projected toward west is deflected toward north by a magnetic field. Okay. So we completed this question in the last class.
Yes, sir.
Okay, let's see some more questions. Okay, let's see this one. Domestic circuit we have to do. And okay. See this question number 10. Okay. So just think of the question. Imagine that you are sitting in a chamber with your back to one wall, an electron beam moving horizontally from back wall towards the front wall is deflected by a strong magnetic field to your right side. Okay. So imagine it in your room. Imagine in your room. The only thing that you have to take care that the direction of movement of electrons is opposite to the direction of current.
Sir, in what terms are we supposed to give the answer?
Direction of magnetic field.
No, like, sir, anti-clockwise, clockwise, north to south, like that.
So if you see it, so how you will observe it?
So we'll
Okay,
observe it in a way it's moving away from us.
Okay, let me try to do this like this. You are sitting in a chamber with your back to one wall, an electron beam moving horizontally from back wall toward the front. So let me say this is your chamber. And in this chamber, suppose if you are sitting over here. Okay, here you are sitting. So this is your back wall. This is your back, front. So this will be your right and this will be your left. Okay. Understood these directions? Now
Yes,
electron beam moving horizontally from back wall toward the front wall. Okay. So electron beam, it's moving like this. This is the direction of motion of electrons. So what should be the direction of current?
opposite side.
Opposite side. So we will take the direction of current to be like this. This will be the direction of current.
Sir,
Yes.
sir, this is Shravani and I couldn't attend. I was unable to attend the classes before, which were taken regarding this lesson because I was not in Hyderabad.
Okay. So, okay, you need a revision of this chapter.
Yes, sir, because this chapter is not, I mean, has not been started in the school. I just so I'm like getting very
Okay,
confused.
so which chapters have you left? Only this magnetic effect or control and coordination also?
Control and coordination is completed, sir. I'm only lagging at this chapter.
Okay, so I will discuss with sir and I will let you know.
Yes, sir.
Okay.
So the movement of
Uh,
magnetic field around the conductor, like the current will be anti-clockwise.
It would be downwards, sir.
Okay, let's see here. We are getting here things we have got. We have got the direction of current, right? So this is the direction of current and the electron beam. It was deflected towards the right. So this is the direction of force experienced. So this is your force and this is your current. Now what should be the direction of field then? Arrange your fingers of your left hand such that first your current is pointing like this in this direction, in the back direction. Okay. Or uh, instead, since I have drawn it over here in front of me, if you draw this in your piece of paper, so you will get it exact. Draw it on a piece of paper in front of you, keep it, and over there your finger, this current should point towards you. Then after this, rotate your hand so that current is over there. Like, so now you have your current pointing towards you, force to pointing towards your right, your thumb pointing towards your right, and the magnetic field is pointing in the downward direction. So just check if you are able to arrange your fingers. Shreyasi,
Yes, sir.
have you been able to arrange?
Yeah, yes, sir.
Sir, even I got it.
Okay, so Manan, also- okay, Shreyasi, you understood this problem?
Yes, sir, yes, sir.
Okay. So as per the situation, and draw the diagram and then you will get your answer. Okay. Somewhere you need to imagine, somewhere you need to draw and then move forward. Let's see if we have some more questions with here you have. There is one more question. Just you people try to do it on your own. I think we did it, but still you try to do this. This 13.2. Did we do? I
Yes,
don't
sir.
think we have done.
We did it.
We have done.
Yes, sir.
Okay. So, okay, just within a few minutes, I will try to find some more problems if there are. So I will share with you to solve them. Okay, regarding the directions of magnetic field. Let's start with the other topic. Okay, here is what this question. I told you I will be telling you this question. So think of this question. This is another very conceptual question. If you are quite clear with your concepts of class 9th, quite clear with your concepts of class 10th, okay. So this you can assume the question to be a very high level question. Which of the following property of a proton can change while it moves freely in a magnetic field? Also, if you read completely, there may be more than one correct answer. It's not an MCQ. There may be more than one correct answer. It's not just one correct answer. So think what property of the proton can change. Okay, will the mass change or not?
No, sir.
No, sir.
Okay, speed.
No, sir.
Why will the speed not change?
Sir, I'm not understanding this question, sir.
So the speed may vary, right?
Sir, it might be velocity.
The velocity and
There can
It
be more
might
than
be
one
velocity.
correct answer.
velocity and momentum.
Yeah, there can be more than one, but it's not necessary that there will be two correct. There may be three correct, there may be only one correct also. That you have to think. Okay, so here I'm telling you something which was as a part of class 9. You have studied it also, but you have not paid much attention to it. Okay. So before that, your correct answer, which of the following property of a proton can change while it moves freely in a magnetic field? So since a proton is a charged particle, right?
Yes, sir.
Proton is a charged particle, it carries a charge and it is moving in a magnetic field. So it is like a current is flowing in a magnetic field. Therefore, the proton will experience a force, right? And if it experiences a force, so there must be an acceleration.
Yes, sir.
Okay. So there must be an acceleration. And if there is an acceleration, then there is a change of velocity. Okay.
Right, sir. Yes.
So what? So your velocity will change. Okay. And if velocity changes, so momentum will always also change, as the formula for momentum is mass into velocity, right? So if the velocity is changing, momentum will also change. Okay. What about speed? Will the speed
Yes.
change or not?
No, sir,
Now
it
we are
won't.
thinking of speed. Speed will change or not? So
No,
Manan,
sir.
why will the speed not change? Why will the speed not change?
Sir, when the force is applied, then there will be a change in velocity, not speed.
So how it is possible then?
Double speed.
That velocity is changing and speed is not changing, and there is force also.
Then maybe the speed is constant.
Change.
So how is the velocity changing then? See how the points are linked. If see, we are saying that it is a charge, so it must experience a force. It will experience a force or not? It will
Yes, sir.
experience a force, right? So force is equal to mass into acceleration. That means there will be an acceleration, and acceleration is equal to v minus u over t. So that means there will be some change of velocity.
Yes, sir. Yes.
Okay. So if there is a change of velocity, so I say that your option third is correct and option fourth is also correct. Like momentum is equal to mass into acceleration. So mass into velocity. So if velocity is changing, momentum will also change. Okay. But what about speed? Will it change or not?
No, sir, the direction is only changing, the speed is not changing.
So, okay, so this was a very quiet answer. That magnetic forces, just keep
Magnitude,
in
sir.
mind, magnetic forces, they are always act perpendicular to the direction of motion of the charges. Okay, And in class 9th, you have studied that if an object is moving, if any object is moving over here, let's say an object is moving like this with some velocity v, and there is a force which is always acting perpendicular to it. If a force always act perpendicular to a motion, so this will only change the direction and not the speed, and therefore it will make the charge go in a circle. The magnetic field will just change the direction of motion. It will not change the magnitude of velocity. Right? So your correct options are option number 3 and 4. Okay. So these were Manan and Mehak who tried. I want everyone to try these questions. You might learn them, but they are taking too many concepts. Right? Let's move. Now we see the next topic, that is domestic home circuits, domestic circuits. So what are domestic circuits? How we connect, how we have connections at our home. So the connections at our home, they are the domestic circuits. Okay, Hasnita had told the answer B and C. Hasnita, now you are clear with the answer?
Yes, sir.
Okay. So in the domestic circuit, that means how we have the connections at our home. Okay. So let us see how the connection is supplied to our home. First of all, you have a power line which is outside, and from the power line, the connection comes to your home in the domestic meter. You have an energy meter at your home, and from the outer power line, this is connected. From the outer power line, the wire line comes to your home directly to the energy meter. Okay. And from here, the work of the electricity department is over. They give you, from the meter, they give you connection into your main switchboard. So you have your main switchboard where you obtain the connection out of the energy meter. And after this, now it's your role how you distribute the connection in your home. Okay. If you see this wire, so there are two wires. One of the wire is called as a phase wire, or this is a phase wire. And it is also called as live wire. It's unlike the DC. If you see in DC, there is a positive wire and negative wire. Here, there is no positive and negative. We make one wire to be the neutral wire. So we make this wire to be the neutral wire. Okay. And the other wire to be the phase wire. So here the current does not flow in the neutral wire. The current only flows in the phase wire or in the live wire. The current does not move into the neutral wire.
So,
It's
sir,
there.
why they connect both of the wires to the switch?
Yeah.
Why did they connect both of the wires to the switch? They can only connect the phase wire. No?
So that is for the completion of the circuit,
Okay.
so that the circuit gets completed. Okay. This current that is supplied at our home, it is the AC current. It is alternating current. Okay. The current supplied at our home is the alternating current. The current which is at our home, that is the DC current or direct current. So DC current or direct current, it is obtained from the battery. Every time we have made a battery or cell, so battery or a cell, they give us direct current. Whereas an alternating current, it is obtained from an alternator or from a generator. So alternating current or AC, it keeps fluctuating, it keeps changing its direction. Okay. So first we understand what is the difference between the AC current and DC current, and then again we will come back to the circuit. Okay. So up to now we have reached there. This is our energy meter, and this is our main switch or main distribution box. From here, all the devices will be connected. So first we see what is alternating current and direct current. Let's see. Direct current and alternating current. Okay. See, why we call it as direct current? As it is directed. It flows in a specific direction. Okay. A current that flows in a specific direction is called as direct current. So current that flow in a single direction. In a direction is direct current. And in what is an alternating current? A current that changes its direction. So a current that changes direction continuously. Direction continuously. There is a change of direction in the AC current or alternating current. Okay. So if you see in an alternating current, it is something like this. Suppose if you have a bulb and has a switch, it's connected with cell. So this is a DC supply. If you have an AC supply, so again you have a switch, a bulb, but now here you have AC source. We represent AC source like this. Okay. So if there is an AC source and here we have the DC source. In the DC source, what will happen? The current will flow in always from positive to negative. It will always flow like this. Positive to negative. The current will flow like this. Okay. This will happen in a DC circuit. But in AC circuit, what will happen? The current will change its direction. That means for a very short duration of time, this side will be positive and this side will be negative. Then in the next interval of time, this side will turn out to be negative, this side will turn out to be positive. Then it will again exchange. Now this will become positive, this will become negative. So the polarity changes and therefore the direction of current also changes. Okay. So sometimes the current flows, for some time the current flows like this, for some time the current flows like this. Okay. So the direction of current, it's not fixed in the AC current, it keeps changing. But in the DC current, in the DC circuit, the direction of current is not changing. As you see at your home, you have sockets, you have those table fans, you have coolers. So if you are ever using your table fan in your socket, so it always revolves in a specific direction. Okay, there is no positive and negative in the AC circuit. So I hope this point is clear that in the AC circuit, the direction keeps on changing, but in the DC circuit, the direction remains the same. Okay. Any other, so this was one point of difference. Direct current, how do we obtain direct current? It is obtained from a battery or cell. A direct current or DC current, it is obtained from battery or cell. And this one, it is obtained from an alternator. So that is why at your home, I think you all of you have heard something about inverters. Yeah, luminous inverters. So Shreyasi, what is the role of the inverter? Yeah, Shreyasi, what is the role of inverter? Saryu, what's the okay? Your name was Saryu, or it was something else pronounced?
Sir?
Your name is Saryu or something else?
Sir, sorry only, sir.
Okay. So, what's the role of inverter? Have you seen an inverter?
Yes, sir. I think it's for storing current.
It's storing current. So why is there a battery then?
Sir, I don't exactly know it, sir.
Okay. So suppose the power goes off at your home. So can we use a battery to supply power to your home?
Yes, sir.
Yes, can we use battery?
So it needs to be a big enough battery to supply to electronics.
Okay, we need a bigger battery. So can we attach? Just disconnect it from the outside and attach it with the battery. So will it work or not?
No, sir.
Why? So just now you're saying it will work.
So only battery won't work. We need something else to. I'm not exactly getting the word, but we need something else in between to supply current to every single electronic.
Okay. So this is not actually what is happening over here. See, our battery supplies DC current. We cannot change the polarity. But at our home, we have AC current. Okay. So all the appliances which are running at our home, they are AC appliances. They will run only on
Sir,
AC
you can
current.
convert DC current to AC current
Oh, yes. We can convert DC current to AC current. And how we will convert that?
using battery,
So by using
Battery
inverter,
by using an
other
inverter.
sources.
No, not other sources. See, what is the battery doing? What is the role of battery? Battery just to store your electric current in the form of chemical energy. Okay. So your battery will provide DC current. Battery will just provide you DC current that is similar to a cell. Like you use cells in a torch. Okay. So it will just supply electrical energy in the form of DC. Then you need an inverter. Okay. Now the role of inverter is that this inverter, it will convert DC current to AC current. It will convert DC to AC of the desired frequency, and then of course you can run your appliances.
Sir, can it also work
Yes.
vice versa? Can also do the same function that from AC to DC.
What convert AC to DC?
Can the inverter change it from AC to DC?
Okay. An inverter does opposite also. It convert AC to DC also, and in that way, it charges the battery.
Okay, sir.
So at your home, if you implement a battery and inverter, so an inverter, when the AC current is coming, it will convert that AC current to DC and supply a part of it to the battery for charging. Okay, so your battery will keep on charging, and your complete home appliance will run on AC only. All of you just wait. Let me charge it. Fine. Okay, let's see. So inverter is there which can convert AC to, it will convert your AC to DC also and DC to DC also, right? So you cannot use a battery directly at your home. You need an inverter which will convert that DC current to AC current. And at home, we are supplied with 220 volt AC source. 220 volt AC. This is a supply line in India, which is 220 volt AC, and it's 50 hertz frequency. The frequency of the AC current is 50 hertz. That means your current moves something like this. It moves from here, goes to the negative, and from the negative it comes back. And this is done about 100 times in a second. The current changes its direction 100 times a second. So there are 50 cycles per second. In 1 second, the current is running 50 cycles like this. Okay. So the bulb which you see, it's not actually running continuously. In fact, in it the current is coming, going, and it is at a very fast rate. Okay, it's a 50 hertz. But the battery that we are using, it has a voltage of around 12 volt. However, you can have bigger combinations also, but we have a general battery rating of 12. This is the general one which we find in the market. They can be joined to increase the voltage and current also. Okay. So the role of inverter is a lot. It will convert your DC to AC. Also, it will increase up the voltage. As the AC devices will not work at 12 volt. They require 220 volt AC and 50 hertz cycle. If you observe in the DC, there is something like, suppose if you have a DC fan. So is there anyone who has used a DC fan or DC motor? Anyone has ever seen a DC fan or a DC motor? No?
That's okay.
There is DC fan like handheld fan, like a small one.
Yeah, the handheld fan that you see, that's a DC fan.
Yes, sir, I have it.
Yes, sir.
Okay. So in that, if you change the polarity, if you change positive to negative and negative to positive, so it will start revolving in the other direction. The direction of revolution will change. Okay. But in case of DC, it never happens. There is no plus and minus on your switch. There is no plus and minus on the board. Whatever size you plug in, it will always run in the same direction. Okay. So in the differences, we write here The second point of difference we have written that DC current it is obtained from a battery or cell and AC current is obtained from an alternator. DC current it cannot be supplied to long distances.
Sir, can DC current change directions? Like,
No, DC current cannot change direction.
okay.
Okay. However, it can become on and off. You can on it, you can turn it off. That can happen, but it cannot change directions.
Sir,
Okay,
what
sir.
are the fans which are in our home? Is it like AC current?
What happened?
So the fans which are in our house, like, are those alternating current?
Fire brigade,
So fans in our house.
fan, they are alternating current. Everything at our home it's running on alternating current, but your mobile phone is running on a DC current. It has a battery in it.
Yeah.
Okay. And your charger, can you say what is the role of your charger?
Sir, to charge the battery?
So how it is charging? Can you directly connect the wire in the socket?
No, sir. We need an adapter which changes AC current into DC current so it can charge our battery.
Yeah, so the charger or adapter, it converts your AC current to DC current. Okay. So we need to convert AC to DC for charging the phone. So that means your phone is actually using DC current. So in the direct current, right, it cannot be transmitted for larger distances. And that is the reason we are using AC current at home. It cannot be transmitted to long distances. Whereas AC, it can be transmitted to long distances. Okay. So AC current, we can transmit it to long distances. Like your city is getting that electric current maybe from thousands of kilometers away, or maybe from 100, 200, 300 kilometer away. But if you transport DC, it will cause a lot of heating effect, and hence it cannot be transmitted. Okay. We can make them graphically something like this. See, if I want to represent DC current over here and I'm representing AC current over here. Okay. So we can represent it like this. So here I'm representing current. On the y-axis, I'm representing current. Here also I represent current. And on the x-axis, I represent. Here also I represent time. So in the DC current, once you put the circuit on, initially your current will be 0, but once you put the switch on, the current will rise to its maximum. And it will remain the same. It will remain the same unless you switch it off. The current will not change. This is what happens in the case of DC current. If you switch it off, so then the current will again become 0. Right? So this is your on position, and here this is your off position. This is also off position. Right? But in the case of AC current, your current is represented something like this. The current will increase to its maximum, decrease to minimum, become negative, again increase to maximum. So this is how the AC current flows. With time, as you can see, in the beginning, the current is 0. Then we switch it on, the current increases to maximum. Then again decreases to 0. then becomes maximum in the opposite direction. That means the current changes direction, it becomes negative. So it changes the direction. Then after that, it again start increasing, increases to the maximum, again decreases to zero, then decreases in the negative direction, increase in the negative direction. Okay. So in this way, we see that the AC current increases as the direction of AC current, it keeps on changing with respect to time. Okay. But in the DC current, you will have a maximum value of current when it is on, and if you turn it off, there will not be any current. So I hope everyone has understood about AC currents and DC currents.
Yes, sir.
Okay, so you must note these points of difference. They are very important. They have been asked in the CBSE exam every alternate year. Every alternate year, you will find a question from the difference between AC and DC. So you can see here the DC current that flow in a direction is direct current, and alternating current is the current that changes direction continuously. DC current, it is obtained from battery or cell. AC current, it is obtained from an alternator. DC current, it cannot be transmitted to long distances, and AC current, it can be transmitted to long distances. Okay. Then at the end, you also have to draw the graph. This is the graph of DC current and graph for the AC current. Okay. And before moving forward, whenever I'm just today, I will send this in the group. So when I send it, just check whatever has been done. Okay, compare it with whatever you are writing, that if you have written it correctly. Okay. Then the next one, we were looking for the domestic circuit. So let's come back to the domestic circuit. Here we had left the domestic circuit. We saw that there is a phase wire, a neutral wire. Okay. The phase wire is the one that carries current. Okay. So phase wire, it carry current. The neutral wire does not carry current, but it is only there for the completion of the circuit, for the circuit to continue. Okay. We had got here that first the connections are provided to the energy meter. Then from the energy meter, after the energy meter, the connection are sent to the main switch. Okay. And in the main switch or main distribution box, you have a fuse line. Okay. Here you have a fuse wire. In between, we find a fuse wire. A fuse wire, it is attached in the live wire, not in the neutral wire. Okay. So a fuse wire is attached, which act as a safety device. And then after that, the current is transmitted. And here all the devices, they are connected in parallel. So here we have a switch for each device. Okay. So there is a switch for each device. Then you have your device. It's connected to the negative. Then you can have another way, another one switch, next device, and it is also connected like this. You have the next. So in this way, you can connect any number of devices. Okay. So in this way, any number of devices can be connected in parallel. So at your home, all the connections which are made, All the connections, they are made in parallel. They are not in series. Okay. So this, why, can anyone guess why do we connect all the devices in parallel and not in series?
So the current supplied will be different for series and parallel, right?
So why are we not connecting them in series? Why are we connecting them in parallel?
Sir, the resistance will be more in series.
Yeah, the resistance.
Will be more if they are connected in series.
The resistance will be more if they are connected in series. So what will be the problem if they are connected in series? If the resistance increases, so what? If we are connecting them in parallel, so the resistance will decrease.
So there'll be more than one
There will be more than one.
path like to travel electricity.
See, why? There are some basic things why we need them in parallel. Okay, just assume that we connect them in series like this. We do not connect, but let us assume that we connect them like this. This is your device one, then another switch, you have your device two, then another switch, you have like this. Okay, so what will happen? Suppose I want to, just call it properly. Suppose I want to run this device one. Okay, so I put this switch on. Will this run or
Sir,
not?
even the second one will be switched off in series.
Will this device one run or not?
It won't run, so the circuit isn't complete.
Circuit isn't complete, so it won't run. So that means if you want to light a bulb, you have to run your fan also. You have to run your TV also. Everything has to run. Are you getting? So in the series, whatever devices we connect, all of them must be connected. All of them must be on. Then only the devices will run. Okay. There will be another problem. Suppose if there is a fault in any of the device. Suppose there is a bulb has fused. So can you run any of them?
No, sir.
No. If the bulb gets fused, so you won't be able to run the fan. You won't be able to use anything, even if the bulb fused. Okay. So a fault in any appliance, it will cause the complete circuit to get fault. But here, what will happen in the case of parallel C? Suppose I want to run this. So I will switch on this. Will it run or not?
Yes, sir, it will.
Yes, sir, it
It
will.
will.
Sir,
Okay.
the others
If I
won't be affected.
others will not be affected, right? If I want to run this, so I can run on this. I can keep others off, and it will run. Okay. I can run all the three. So this is one of the benefit of the parallel connection, which we cannot use in the series circuit. Okay. Now there is another problem with the series circuit, that after every device, there will be a potential drop. Okay. For example, there will be some potential drop over here. There will be some potential drop over here. So all the devices, they will have some potential drops. Okay. So if you are, that means you have to supply a larger amount of voltage. You have to
Sir, in
supply a
parallel
very large voltage.
combination,
Yeah. In the series
sir,
combination.
each appliance gets full voltage in parallel, no?
Yeah, in parallel, every appliance is getting the same voltage. Suppose if you are supplying here 220 volt, so each of the appliance is getting 220 volt. Okay, so every appliance is getting 220 volt. Okay. Here there is distribution of current only. If suppose here we have 5 ampere current, so out of that some current will pass to this, some current will pass to this, and some will pass to this. So there is just distribution of current. There is no distribution of voltage in parallel. Now, this is also an important question. You will try to write down the answer, that why we prefer parallel connection and not series connection. Why we prefer parallel connection for domestic circuit?
Sir,
Yes.
first in parallel connection, we don't need a higher voltage, like a larger voltage.
No, in the parallel connection, whatever power rating we are making, suppose in the USA they are supplying us at 110 volt. Okay, so all the devices, they are manufactured for run at 110 volt. They are not manufactured to run at 220 volt.
Okay.
So whatever you want, you can make it. But in the case of series combination, you have every device will take up different potential. There will be voltage drop. So that means here you need to supply a large amount of voltage and a large amount of current. Current will decrease and voltage will increase in the case of series combination. Okay. So I want a proper answer to this question. Try to answer this question properly. Why we prefer parallel connection for domestic circuit? Okay. Then here we have seen another thing, a fuse wire. For the fuse wire, we will discuss in the next class. What is a fuse wire? Why do we use it? Okay. Apart from this, we also use a earth wire. Okay. So that our device is also connected with an earth wire. So earth wire also act as a safety device. Our earth wire is also a safety device which is used to earth or ground the leakage currents. We will discuss about these two in the next class. We will discuss about fuse wire and earth wire in the next class.